Hello dear friends, welcome back to Chayarani's maths class. Before we solved the problems of inverse functions of relations and functions in class 12, here also one more problem let we solve. It is also most important, many times repeated in exam. Observe the problem here. Show that f from minus 1 to 1 to r given by f of x equal to x by x plus 2 is 1 to 1. Find the inverse function. See, if the problem is like this, we are going to solve by two different methods. One is we have to check for 1, 1 and onto, then we can write our inverse function and we can conclude that as invertible. Or as usual we solved before, now the same way, f of x function let we write and calculate our y function. Then by using the composition function, we can prove that the function is inverse. So we can solve it by two different methods. So let we solve by first method, that means 1 1 and onto method. Observe the given function. What it is given? F of x equal to x by x plus 2. So to prove the function is 1 1, we have to consider two images and we have to prove for two pre-images. If f of x equal to x by x plus 2, then f of y, it is equal to y by y plus 2. Consider two images are equal. If f of x equal to f of y, then x by x plus 2, it is equal to y by y plus 2. Cross multiply this. What will you get? X into y plus 2, it is equal to y into x plus 2. xy plus 2x, it is equal to xy plus 2y. Here xy get cancelled. You will get 2x equal to 2y. So 2 will get cancelled. X equal to y. This is proof for all x comma y belongs to domain. What is the domain here? Minus 1 to 1. So you can conclude that f is 1 to 1. F is 1 to 1. Next you have to prove for f is onto, and also you can find the inverse function. How you prove that f is onto? For that, you consider your f of x function, f of x equal to x by x plus 2. Consider f of x equal to y. So f of x is x by x plus 2, it is equal to y. Cross multiply this. X equal to y into x plus 2. So what will you get? X equal to xy plus 2y. You want to solve this for x, so that shift this xy to the LHS part. Xy equal to 2y. Take the common term x outside, left with 1 minus y equal to 2y. So what is left? 1x is equal to 2y divided by 1 minus y. See, this is our g function. That means x in terms of y. This is for all y belongs to, what is our codomain? It is R. So you can say that f is onto and inverse function exists. F inverse is nothing but g of y function, that is 2y by 1 minus y. If f is 1 1 and onto, you can say that f is invertible. If it is invertible, another method is there to prove this. We already solved many problems in that method. That method also let we solve. You can use this method, 1 1 and onto method. Here we solved 1 1 and onto, and you can conclude your f inverse function. Similarly, one more function. How can you solve that? As usual, you have to consider your f of x function. It is equal to x by x plus 2. Then consider f of x equal to y. As usual, you solve. Then this you will get x equal to 2y by 1 minus y. This function, what we will call it as g of y function. After this, we have to consider the FOG function. FOG. It is equal to f of g of, what it is? Y. So what is our g of y? This one, what we solved, no, that one. F of g of y equal to 2y by 1 minus y. So this is f of x. In place of x, we have this term. What is our f of x? We know that our f of x is x by x plus 2. So in place of x you put this 2y divided by 1 minus y, x divided by x plus 2. Again our x is 2y by 1 minus y plus 2 it is, x plus 2. Now you simplify this, 2y divided by 1 minus y whole divided by, take LCM, 2y plus 2y minus 2y it becomes, divide by 2y minus 2, right, it is divide by 1 minus y. So 1 minus y get cancelled. So left with what? 2y divided by. Here plus 2y minus 2y get cancelled. So 2y divided by 2 it is. 2 will get cancelled y. So our FOG function, it is nothing but y. It can be written as IY. After solve for FOG, we have to solve for GOF. GOF is nothing but G of f of x. So G of, what is our f of x function? Our f of x function is x by x plus 2. This is our f of x function, x by x plus 2. So G of y, what is our G of y function? It is 2y by 1 minus y. Let you take G of y, it is 2. Y is x by x plus 2 divide by what it is 1 minus y, 1 minus, again y is x by x plus 2. Now you simplify this, 2x divided by x plus 2 whole divided by, take LCM, x plus 2 minus x divided by x plus 2. Okay, x plus 2 get cancelled. Here plus x minus x get cancelled. You will get 2x by 2. 2 will get cancelled. It is x. So our GOF function is x. It is nothing but Ix. Observe here FOG and GOF function we got. So we can write f is invertible. We can write f is invertible. So our invert function is f inverse is, what is our y function, that you have to write. Our y function where it is 2y by 1 minus y. This is nothing but g of y. If f function is invertible, it is 1 1 and onto. The statement is vice versa. Function is invertible, you can say the function is 1 1 and onto, or if the function is 1 1 and onto, you can conclude function is invertible. Hence the problem. Observe clearly here, I solved by two different methods. You can follow up any one of the method. Either you prove the function is 1 1 and onto and conclude function is invertible and inverse function, or you find your g of y function by using the second part, same working procedure. Then you solve for FOG and GOF and you conclude f is invertible and your inverse function is. Any one of the method you can follow.